Hello guys, today we're going to find out how iPhone X display circuit works. The screen of the phone is the most important part. That displays information the phone needs to convey to the user. iPhone X with OLED flexible screen. Each pixel can be self-luminous, so the backlight is not required for iPhone X. The circuit structure of the display is simplified. Malfunction display circuit can cause issues like flickering screen, no display, and normal display, etc. So first, let's take a look at the main components related with display circuit. First, Q1000 CPU. It just like the brain performs as an overall controller and transmits image information by MIPI bus. U2700 PMU is provides power supply for the display circuit. U3300 charging IC is also used to supply the power for display circuit. J5700 display connector. It makes possible the connection between OLED screen and the logic board. Okay, let's take an overview about chips, CPU, the brain, for overall control and transfer the image data by MIPI bus. The PMU, the heart, provides powers for the display circuit. The charging IC is also support to provide power for display circuit. Display connector, the bridge between the OLED screen and the motherboard. Okay, so it looks not very complex. Then let's come to the block diagram. Okay, so let's see how it works in details. In the display circuit, the four powers required. The first one is PPVDD main halo sent out from charging IC to display connector. The second one is sent out from PMU to display connector, PP1 volt 8 and PP3 volt. Okay, so here we have 3 powers already. How about the last one? The last one is here. Normally the power will start with PP. Okay, so the last power is PP1 volt sent out from PMU to display connector. So till now, the power is fulfilled. After that, a reset signal will send out from CPU to the display connector. Then, the image data will be transferred from CPU to display connector by the MIPI bus. Okay, so this is a very basic working process. Also, there's some rails we do not mention them. So let's take a look. This one, display to PMU AMUX connector. This one is PMU to display panic B connector. And ISP to display flash interrupt. Display to AP alive. Okay, so for the 4 rails of signals, they have no influence to display function even being detached off. Our engineer have to do some tests, for example, remove inductor or resistor. The display function is good. So based on repair level, we will not deep study about the rails. For example, AMUX, this rail, and the panic B, they are mainly used for reporting the abnormal display information only. There's no effect to the display function. Okay. So this circuit, let's have a brief summary. Power first, then reset, then image data transfers to the MIPI bus. Okay. It's relatively simple. So we will also share some ideas about the normal circuit working sequence. For the iPhone circuit, the working sequence normally follows power first, then clock, reset, control, enable, data, and feedback. Some sequence like this. Okay, this kind of sequence I think is designed based on their human behavior. So for easy to remember this kind of sequence, I will share some ideas. For example, we can treat the circuit as a person. So if you want to drive a person to work, the first step, the person should get some energy, power. So he should eat and drink to get power, right? In the second step, he need to do some job to make the living. So he need to go to some company to work. Okay. And for most company, you should go to work on time. So you should set clock to go to work on time. Okay. After that, when you're in the office, you should reset yourself. No matter it's good or bad on yesterday, you should reset yourself because today is a new beginning. Okay. After that, you should do the work based on the company rules. If you're the boss, you should also control the laws or the society rules. Sometimes it's kind of enable signal. If you're not working for salary, not working for money, not working for their dreams, you need some enable signal, just like the motivations. Okay. After that, you should output something. For example, today I fixed 10 pieces of motherboard and I refurbished 5 pieces of screens. So this kind of data should feed back to the boss. Okay. And sometimes you should also feed back some abnormal information. For example, when you are tired, when you are sick, you should report to your manager or to your boss. The circuit is the same. In some circuit, we should also feed back information. Like the charging circuit, we should feed back the battery information to the CPU. And like the flash circuit, we should also have the ADC circuit to feed back the temperature for protection. And what else? Like the speaker circuit, there's also some circuit to feed back the voltage to protect the circuit. Here is an example for your understanding. Okay? Just like Albert Einstein said, imagination is more important than knowledge. So, based on repair, if you can remember the sequence, that should be very great. And one more tip is, this sequence is for reference only. Because not all the circuits follow the sequence like this. For example, in this display circuit, power first, power, and then we have the clock, then reset, then the control enable, then it's data MITEBA, also then no feedback. So this one only for reference, not all circuits with these factors. And in some circuits, maybe the sequence is a little bit different. For example, power first, then reset, then clock. Okay? So we will learn the details in future little by little. Okay, so that's the sharing about my own learning experience. I hope this course could be helpful to your repair. Okay, so that's all for today. See you next course.